Hey there guys, my name is Max, and today I'm going to be showing you how to do this kind of Euphoria type ragdoll. I'm mostly doing this tutorial because I have never seen anybody actually do something like this, and if they do, it's either paid assets or something that it's not even straight into the point and it's like 3 hours of video. So yeah, I will be splitting this tutorial into 3 parts, so it's not 3 hours long too. And yeah, let's dive right into the showcase. Hey there guys, and welcome to part number 1 of this tutorial series of Euphoria type ragdolls using Advanced Locomotion System version 4. The thing that we will be doing today is using a blank project. I have it here, as you can see, the ragdolls.
Ew, dude! What the fuck?
And in this tutorial, we're just going to be covering the basics. The bracing system with the animations. That's it. So yeah. Go ahead and open up your project, and once you have it opened, we're going to go into Content Drawer, Advanced Locomotion System version 4, Blueprints, Character Logic, and open our character blueprint. Not the base character, but the Anim-Man character blueprint. Open it, and if we are thrown up into the embed graph, go ahead and go back to the viewport that is on the top left corner. Boom, viewport, and you will see your character here. Now, what is the first thing that we're going to do? We're going to create a collision for the character, so whenever something touches the character or collision, it will fire a function that will make us brace. So, on the top left part of our corner screen, we will see an add into our components tab. Click add and just look for capsule collision and rename it to something you want. I'm just going to name it brace. Great. Now, instead of it being inside of the capsule as well, make it be inside of the mesh. So just drag and drop it into the mesh, and we're good to go. Now, as you can see, it's not actually fitting our character. So into the details tab, we have the capsule height and capsule radius. But before editing any of that, we're going to make sure that we parent the socket. So parent socket, make sure to click here and to select a different parent socket and select the pelvis. It will mess up a little bit of the rotation and location. Just make sure to go here into the transform and reset these. And now just rotation, make the y-axis 90. Now we're good to go to edit our capsule height and capsule radius. So I'm just going to make it a little bit taller than the actual capsule that the Advanced Locomotion System character has. So around here. Make sure and keep in mind that this is what will make our character fire up the bracing animation. So if you want it to fire up, I don't know, if you're falling and you want it to fire up quicker, or actually fire up in time before it hits the ground, you can just, instead of making a capsule collision, you can make it a spherical collision. But yeah, personally, I'm gonna do it like this. Now, go ahead and uncheck hidden in game and compile. Why are we gonna unhide it in the game? Make it visible? Because I want to see that if we ragdoll, it falls with us, it follows the body. If we do not parent the socket, let's redo this. If we do not parent the socket, it will stay floating when we fall, which is exactly what we do not want. Why? Because imagine you're falling and it doesn't actually know when you're going to touch the ground or when the ground is actually beneath you. Great, so now we can hide it again. And we're pretty much done with our collision. Now let's make the system that actually fires it. So we're going to go ahead back into our demo level or wherever and just open your content drawer and go back to Advanced Locomotion System version 4 and look for anim. And we want the ALS anim BPS animation blueprint. Go ahead and open that up. And you're probably going to be greeted with the animation graph or maybe the Ragdoll state update graph, whatever. We only need to do this. So go ahead and scroll down into my blueprint section so you get into the variable section. I already created these. I'm going to delete them because I'm going to show you guys how to do them. And what are we going to do? We're going to create two variables. The first one is going to be called is bracing. And basically, we're going to fire this boolean whenever the capsule collision is detecting a collision. And we're going to fire it up into our animation graph playing a ragdoll animation, the bracing one. And now we're going to create another one called brace physics alpha. This is just to know when to play it. Make sure to change it from boolean to float. Great, we can compile for now. And we're going to do the next big step. This is one of the most important steps. We're going to go into our content drawer. I'm going to delete this. And just look for pose. Pose. I already created this pose. If you want to use it, I will leave you a link below so you can grab it and download it. But if you want to make your own animation, this is what I recommend you doing. Grab your T-pose, right click, and then duplicate and rename it to whatever. Then I'm just going to open whatever. And we will be greeted with this screen. This is like pilot commands. You don't know what to do. If you do, that's great. If you don't, let me show you real quick. Well, first of all, I'm going to pause this because it's too much movement for me. On the left side of our screen, we have our skeleton tree, where we can select each bone and animate it and create a pose. So we're just going to pose up our character. Make sure to keep in mind that this is a bracing system. It's going to be the animation that it's going to play whenever something is with collision with our character, a ground or something. Your character is trying to cover himself up. So here are some references of what you could do. And yeah, once you have that done, you can just go ahead and right click your whatever and create an animation montage and rename it as however you want. And now let's say you animated this. I'm just going to animate the clavicle and the lower arm. I'm not actually going to do an animation because I already have mine. Now, if you go ahead and open your animation montage, you will see that it actually does not display the real animation whenever we try to fire it up. Right now it could be showing, but on the real game, when we try to play it, it won't fire up. It will fire the actual T-pose. What do we need to do? Go ahead and select again your animation sequence and select all the bones that you used. All of them. I only used the clavicle and the lower arm, if I am not wrong. Clavicle and lower arm. I'm going to select the upper arm just in case. And click S on your keyboard. This will create keyframes. And these keyframes will actually make our animation work correctly. Great. Now, I already have my animation, so what are we going to do now? We're going to go into our animation character blueprint, and we're actually going to make the system of what happens whenever we enter in collision, or well, the capsule enters in collision with something that is not our character, obviously. So let's go ahead and do this. go into your details tab and scroll all the way down until you see uncomponent begin overlap and uncomponent end overlap. We're going to create 2 of them like so. Separate them. Great. Now, remember the variable we created here called isBracing? We're going to use it in here. So on component begin overlap, move the execution node to create another one, and make sure to turn off context sensitive. And just look for isBracing. And now you will be prompted with 2, get or set. We're going to set isBracing as true. Then, inside of here, in our variables in the main character blueprint, we're going to create another one, and it's going to be called overlap count. And make sure this, instead of being a boolean, it's an integer. Now we're going to select it, drop it, and get it. Instead of setting it, we're going to get it. And drag and drop the node and just put 2 plus signs. Increment integer. We're just going to put this here. And now we're going to drag and drop again the integer amount here and do equal equal. Just equal. And we're going to put 1. So whenever on component begin overlap, whenever it overlaps, it's going to set isBracing to true. What does it do now? As of now, nothing. But we're going to make it play the animation. Now we're going to create a branch. Just you can do by right clicking and selecting branch, or just clicking B and clicking with your mouse. We're going to select and put the execution pin of the plus plus into our branch. In the condition, it shall be the equals 1. And now whenever this equals 1, we're going to create another branch. And here, the condition, we're going to promote to variable, and we're going to call this ragdolling. So, if it's overlapping, it's going to set bracing to true. It's going to set the overlap count to 1. And if the overlap count equals 1 and ragdolling equals, well, we're ragdolling, that we're actually haven't set the ragdolling yet, but we will. We need to make sure that is actually bracing, you know? So go ahead and on the left side of your components tab, just grab your mesh, and we're going to get it here. And just drag and drop the node and put get anim instance. Now, what this will do is actually get our animation blueprint and all of the nodes that and variables that it has. Now we can go ahead and return value. We're going to cast to ALS anim BP as the animation blueprint, and make sure this is a very important step to right click and convert to pure cast. Now make sure so the blue pin goes into our target and set isBracing, and create another node from the blue output and isBracing. We're going to get isBracing. And now we're going to create another branch. We have 3 branches now. Wow. And the condition will be isBracing. Okay, a lot of branches. Now we can go ahead and do this, but on the overlap ending, we're just going to do minus minus decrement int. Go ahead and select get our overlap count. Now here, instead of equals equals, we're going to do a minus equals, less equal 0. Another branch, and the condition will be, you guessed it, minus equals 0. And that is it for now. We're going to hop on back to our animation blueprint. And we're going to make the system so it actually plays the animation. So go ahead and go into your animation graph, not your event graph, not update graph, no, animation graph, and scroll all the way to the right. Before your output pose, you will see Ragdoll states. Go ahead and disconnect Ragdoll states from the Ragdoll pose. You can just click Alt and then left mouse click, and it will disconnect it. Now right click and look for blend poses by bool. So or Ragdoll states will be your false pose, which is basically the flailing animation, the one that is flapping his arms around and his legs when he's free falling. And now we're just going to right click again and look for our bracing pose. So I'm just going to search for bracing. Play ALS bracing pose. Not evaluate, play. Great, and now we can just plug this into our true pose. Now, we have blend times. True blend times, how much time it's going to take for the bracing pose to play. I'm going to set this to 0.6. And the false blend time, I'm just going to set this into 0.5. Now, active value, we're going to drag and drop and get our isBracing variable and put it into active value. So whenever we set isBracing into our animation character blueprint, it will fire this function up. And we can just plug this into Ragdoll pose and compile. Now, we're not done yet. We're going to go back into our animation blueprint character and we're going to create a timeline. So just right click, add timeline. And we can just rename this bracing. We can double click to get inside of it. Add a new float track here in the left hand side. Track, add a float track, and rename this to however you want. I'm just going to name it bracing. Now, this is going to set the actual time for good blend-ins. So we can just set the length into something small. I'm going to put it into 0.7. Now right click, add key, and we have the time and the value. Make sure the time is 0 and value is 0. And now right click again, add key. Time is to the end of your timeline, which is 0.7 for me. And value equals 1. So it is a from 0 to 1 from start to end. That is basically what we want. Go back to the event graph, and now the true value of this branch is going to go into play from start. And the reverse value will go into our true value from the equals minus equals 0. Now that we have this, you would think it should be playing by now, and well, would you look at that? It is actually playing, but it is pretty strange. It's not working completely. And if we actually jump, it doesn't care if it's actually colliding with something. How can we fix this? Worry do not, because as you can see, it's setting isBracing to true, but it never sets it to false. So what are we going to do now? As you can see, after we created our bracing timeline name, it creating a new float variable. And remember the variable we created here called brace physics alpha? We're actually going to use it here. So go back into your animation blueprints and disconnect your output pose. We're not going to need this for now. So just right click wherever and just look for rigid body. It should be with the blue input and blue output. Now you can just drag and drop this to here. It will automatically convert it local to component so it fits. And now make sure the brace physics alpha, get it, and this is going to set as our alpha. Now go ahead and connect this into the end, component to local, and if we compile, there should be no errors whatsoever. Now you have to come here and inside of rigid body, make sure to override physics assets as animation man physics assets. Compile this, and we're good to go now. So go ahead and go back into your animation man character blueprint. Now go ahead and drag a blue output pin from cast to ALS animation blueprint. Make sure to have context sensitive off as well. And set brace physics alpha. The blue pin, make sure the brace physics alpha node is going into bracing. And the execution is going into update. Now, let's take a look at our direction pin. It's an enum pin. So we're going to drag it and just put equals equal enum. This is very important. Equal enum. If you do equal, it's going to be from a number. We don't want that. We want equal enum. And change the value from forward to backward. Now go ahead and create another branch and put the execution pin from finished into our branch, and the condition is backward. And if this is true, guess what we're going to do? We're going to set our is bracing into false. So I'm just going to copy this, set is bracing to false, and target will be this blue pin from cast to ALS animation blueprint. Now, if we go ahead and try this out, it works. Great. So I can just go ahead and fall here. And as you can see, it comes back to my flail animation. Now, if you want it, if you think it's probably too slow, go ahead and change the length from 0.7 to, let's say, 0.5, and the value from time 0.7 to 0.5. I apologize, 0.5. Now if we press play, it's going to be way faster by 2 milliseconds to go to the flailing animation. Isn't that great? I hope you guys enjoyed this tutorial. I will see you in the next part. We're going to be talking about the actual collisions with the mesh, what we're going to do whenever the character hits the ground. And yeah, have a nice day, and please leave a like, subscribe, because I am doing this that I'm pretty sure no one else is doing. See you later.